Hey guys, Hardly Brief Dan here with episode 36 of our Unity Make an RPG series, and today we're going to finish up our camera controller for our third-person camera. Now, I know last time I was trying to figure out whether or not we were going to do terrain or the camera again, and I decided to do the camera this time. In the next episode, we're going to jump in and create some terrain. But the reason why I wanted to do finish the camera is because we're missing one pretty important piece, and I've mentioned it several times. I didn't realize, I guess it clicked after I had recorded that last video and was thinking about if I should do terrain or not. I was playing around with the camera, and the camera goes through the floor. And that made me realize, that I need to finish the camera before we jump on to other things. So today we're going to work on detecting, excuse me for the noise outside, we're going to be detecting the collision of the camera. So we're going to see if the camera collides with stuff, and if it does, we want it to stop. We don't want it to keep going. We want it to stop, just like the player when it runs into a wall. Here, I'll even show it. So just like the player when it runs into this wall, you see it can't go any further. That's collision, right? This capsule's hitting something solid, and we're not allowing it to go in it. And that's what we want to do with the camera. But as of right now, the camera can go inside of it, right? See, like right now, we're inside that piece. We don't want that. Here, we can watch it even go in right now. See how the camera is going in? If you look up here in the scene view, you can see the camera going in the wall. And we want it to stop. Like, we want this as far as it can go. Okay, we don't want it in the wall. The other issue, and this is what made me think about it, was I was running around and I flipped the camera to the floor. Now, if you don't know this, terrains in Unity and in most 3D engines are not actually solid pieces. Like, it's basically a bumpy plane. It's like this. See this plane that we created a while ago? It's basically like this, but with like lumps in it. It's not like a solid piece of ground or anything like that. You can create that, but it doesn't look like this block, right? So basically, to go a little more in depth, basically like this engine is only rendering what's visible. So it's rendering these 3 sides and then the other 2. So these 5 total sides, and that's because it has these vertex that are facing out, and the physics engine knows to calculate that because the camera can see it. And on a terrain generation, which we'll jump into next time, it does basically the same thing. And so, in reality, you don't need to see what's below it unless you model that specifically. But otherwise, it's useless. It's wasted space. It's wasted CPU power, wasted GPU power to calculate all that mass, if you will. So what we want to stop the camera from doing is going under that. So like, say you're running up a hill, and the player gets over the hill, but you zoomed out enough that the camera can fall into the hill. Instead of that camera actually going under the terrain and seeing all the dark undersides, nothing pretty down there, we can stop that by using collision detection, and that's what we're going to do today. So, sorry for the long-winded explanation, but that's what we're going to do today. Next time, in the next video, we're going to do terrain, have something better to look at than this crappy hexagon green pattern that I picked a while ago. So, right now I'm in our camera controller script in Model Develop. And last time we added this else if statement that basically allowed the camera to slowly rotate behind the player if the player was not holding the left mouse button and either going forward or left or right. So today what we're going to do is add collision. So the first thing we're going to do is create a ray cast hit variable, and we're going to call it collision hit. And basically this is going to return a value when the raycast is shot out of the player, or the target, excuse me. It's gonna, or I guess it's the camera in this case. When it shoots out of the camera, it's gonna tell us if we hit something. And we're actually gonna use a line cast, which is a straight line that comes out to tell us what we hit and where we are. So now that we have our collision hit, we're gonna create a new vector 3. We're going to call it camera target position. We're going to set that equal to a new vector 3. And we're going to assign the variables ourselves. So you might be wondering why I'm doing it like this instead of, let's say, you could, I'll show you guys, you could do something like this where we go, gonna go ahead and copy this. So this is because, let me comment this out real fast. So I'm manually assigning which, like the X, Y, Z values in this code up here where I just commented out. But what you could do, the other way to do this is just set the camera target position equal to camera target dot position. Right? This is a vector. This returns a vector 3. This camera target dot position and sets it equal to this vector 3. But the reason why we're not doing that is because we're going to actually add a value to it. So let me uncomment this out. So we have our X, and the value that we're going to add is our camera target dot position dot Y, and we're going to add the target's height. So this is where it depends. If you're using the capsule, then we're going to go with 1.5 because that's the size of our capsule. I think, actually, let me double check that. Capsule, yeah. Oh, that's not the capsule. 1.5. Yeah. So actually, it's gonna be 1 because we have scales 1. So jump back into the script. So we're actually gonna be adding a 1 to it, 1.0. So depending on, we should do 1. Depending on your character, say you're using a model that you created or you downloaded, whatever, check the scale or the height of it because this is where you want to add it. And you can even create a public variable. Up here, you can create a public variable, say public float. I'll type it out real quick. What you can do is go public float camera target height is equal to, I'm just going to say 1.0f right now. Control F to save. If we go into Unity, you can see that variable there now on our camera script. Let me stop. I don't know why it's not showing up. Oh, let me comment this out. It's not showing up because we have an error down here. Control S to save. Jump back into Unity. Should show up now. Yep, okay. Here's our camera target height. So I just added that. I misspelled height. I forgot the T. But I just added that so that you can edit it depending on if how tall your player is. It's super easy to edit that like that. So say we did that. I'll just, since we have it, I'll use it. So I'll copy that variable that we just created. I'm going to uncomment this line of code again. I'm going to go ahead and erase this one and put a variable in there. And this allows it, this is better because it allows you guys to adjust the code depending on how tall your player model is, or if you're using the capsule, you can just leave it how it is. Then the next variable we're going to grab is camera target dot position dot z. So now we got the camera's target's position plus our height, which we needed, and we set that equal to a new vector 3. So the next thing we're going to do is actually create the if statement where it's going to see if there was a collision, and then correct the camera. So we're going to create a bool. And it's going to be is corrected. It's equal to false. We're going to go if physics dot line cast, and that takes, as you can see, it takes a vector 3 start and end, and we're going to do camera target position, and then we're going to end it at our position. So our transform, or we actually have a position variable up above. I mean, this position variable comes from right here, this vector 3 that we've already calculated. And then it out raycast hit info, and this is where we're going to go out, out, not our, out raycast hit info, which in our case is our collision hit. So this is going to tell us if we have a hit or not. And then we can do things if we do have a hit. And I'm forgetting, missing a parentheses right here. So now we're going to set the position. So if we do have a hit, we're going to set the position equal to a collision, or the collision hit dot point. And we're going to corrected distance, which we have. is equal to a vector 3 dot distance, which a vector 3 dot distance is the distance between point A and point B. So we're going to get the distance between our target's position, our camera target's position, and our position itself of the camera. So what this is doing, so we've recognized that we got a hit, and we're going to set the hit equal to our position. So the raycast is basically, it's a vector 3, you can say, and we're going to set that equal to our position. Really, the point right here is the vector 3, and we're going to set that equal to the position, and then we're going to find our correct distance. This is the distance between the camera and the player, and that is going to be calculated by this distance function, which basically calculates the distance between 2 points. In this case, 2 points of vector 3. So it's going to calculate distance between x, y, and z of A and x, y, and z of B. Hopefully you understand that. And if we do this, if this line cast does hit, then we're going to go is corrected. And we're going to set that equal, is corrected, is equal to true. So now, real quick, we got our collision hit variable. We're calculating the target's, or the camera target's position, the player. We're shooting a line cast out, seeing if we're actually hitting anything. If we do hit something, we're going to set that we did hit is corrected value true, because we're getting our corrected distance using vector 3 dot distance. Hopefully I didn't go too fast. Hopefully you guys do understand that. The next thing we're going to do is we're going to use a variable called, or not a variable, but a operator that is a conditional operator. And but real quick, I'm going to add a new variable. Up here, we're going to make a private float. We're going to call it current distance. Now, a conditional operator, you can definitely should look it up, but basically it takes the form of this. It's a question mark, a question mark and a colon. And a question mark and a colon, the best way to explain it, I looked it up myself, this is something I've learned recently, but from Microsoft C# site, this is the condition. This is what a conditional operator does, the question mark and colon. And it allows you to have a condition, and it allows it, basically it does an if-else statement for you in a single line of code. So it's saying, here's the condition, and if this condition is true, then it's going to do the first expression. However, if the condition's false, then it's going to go with the second expression. So this is like saying if, for the example they use on their website, it's if input is greater than 0, then we'll say it's positive. If it's less than 0, then we'll say it's negative. And what you can do for that, let's say it's that example, you go input, if it's greater than 0, you do the question mark and you go is positive, and then you do is negative. So that would be the syntax. That's how you would type it out if we were using input greater than 0 and wanted to know if it was positive or negative. So that's the basic idea of what this conditional operator is, and we're going to be using that today. So we're going to use our new variable, current distance, and we're going to set that to this conditional operator. We're going to say is corrected. So we're saying the exclamation point is corrected, saying if this is false. So if is corrected is false, or corrected distance is greater than current distance. And here we're going to write our expressions. The first one's going to be math_lerp. And we're going to do, remember the lerp function is going to calculate 2 points continuously in between each other. It's going to calculate a value in between 2 points continuously. So the first thing we're going to do is going to do current distance, corrected distance, time, dot delta time. So we have a smoothing. And then we're going to use this same value that we used up here, this zoom rate. I'm going to go ahead and copy zoom rate. That's our first expression. Our second expression is going to be corrected distance. So, what is this saying? Well, if our distance wasn't corrected, then we're going to do the alert. However, if corrected distance is greater than current distance, then we're going to do corrected distance. Pretty simple. Just a shorthand way of doing if-else statements. It's a way to eliminate it. I know I got a comment. Someone asked me about why I use if-else statements. Well, there's a good way not to use them all the time. Learning the shorthand and stuff, I'm still learning. I'm not a great programmer. Trying my best to get better. And that's something that I can do, is using these conditional operators. So the next thing that we need to change is a position calculation. So since we already calculated our position, but we need to recalculate it, and we need to recalculate it for a few reasons. But mainly because we have this current distance variable and it needs to be used. So we're going to go ahead and do position. We're going to set that equal to camera target dot position. We're going to subtract that, or we're going to subtract rotation times vector 3 forward times current distance plus a new vector 3. And we're going to set that equal to 0, negative our camera target height, and 0. I think I'm missing a parentheses. There we go. So this is our new calculation. You can compare it to the old one. It's basically the same thing. I'm going to jump into Unity, see if we have any errors. Hopefully we don't. We might have a few warnings, which we do. I'm going to go ahead and press play. And the camera's stuck. Alright, so we have an error. And what we need to do, we don't have an error, but the camera's stuck for now, and we got to figure out why. And I'm going to pause right here, and I'll be right back. Alright, so I found the problem, and it's something I completely overlooked. It's a very, very simple fix. But basically, what I didn't do at the beginning of the script is set our distance values that we created, our desired current and correct distance, to our starting distance, which is 3. So it was getting the camera was actually stuck. It was continuously hitting the player, and it was resetting itself. So go ahead and add these 3 lines of code. Current distance is equal to distance, desired distance is equal to distance, and corrected distance is equal to distance. So when it first starts, it'll start away from the player, and we'll get the desired functionality that we're looking for. The next thing I changed was I was playing around with how the camera operated, and I changed our camera target height to 1.5, which is the height of our capsule instead of 1. So it's a great thing that we created this camera target height variable, very easy to edit. So I'm going to go ahead and show you what the camera's doing. So here's our camera. We're zooming in. I'm going to actually see how I'm going to run to this wall, and you're going to see the camera come to the player. I'm not doing that. This is the raycast hitting the wall and coming to the player. So this will allow the camera. It can't go in the wall. So if you remember correctly, last time this camera, when I was rotating around, was actually going in this cube, but now it can't do that. It's going to come back to the player. See? It's better to look in the scene view. You can actually see the camera popping back. Perfect. So now, also, another way to check, we can't go through the floor, which we could do before, and we don't want to do. So we got our camera controller done. We have a third-person working camera. You might have used a Unity one, but we've coded our own. Hopefully you guys have learned something from the camera controller. I know I sure have. It's been fun doing and coding for you guys. In the next video, we're going to do some terrain. We're going to get rid of this ugly, ugly green hexagon for maybe more of a green, hilly plain. But That's what to look for in the next video. I hope you enjoyed this video. Hope you learned something. Please like, subscribe, and share, and I'll talk to you guys next time.